Question 12 of the May 2018 AS Paper 1 Edexcel exam board. So trigonometry question here, part A and part B. Part A is pretty standard really, and to be honest so is part B really. So this is quite a common type of question and a really important one for you to be comfortable with. Okay, so let's get on with part A. Just to quickly mention this graph on the left hand side I will talk about in a minute. Okay, we've got an equation here that has got a cos theta, a sine theta and a tan theta in it, and we're being asked to show that it can be written in this form. Okay, and the thing to notice here really is that this form that they want us to write it in has only got cos in it, so that actually really gives you a big clue as to what you need to change in the first equation so that we can head towards this. Okay, so anything with cos in it you want to leave that alone, and anything that hasn't got cos in it you need to change. Okay, but it is really important that you would be able to get to this form even if it didn't suggest it. Okay, so I'm going to try and tackle it from that point of view. So let's just write this equation out. So the way I would really want you to look at this equation if you were solving this without any hints is to kind of think that you've got three things. You've got sine and cos and tan in it, but the thing with tan is tan can always be changed into sine over cos. Okay, now you might look at that and think, well, why has that helped? Well, it's helped because we had three things in it, sine, cos and tan, and now we've only got two things in it, sine and cos. So we've already reduced the number of things that we've got in there. Okay, once you've done that step, the next step really is more of an algebraic step. I would encourage all of my students when they're rearranging algebra that if you've got fraction in your algebra is that you would multiply through by the bottom of the fraction. Okay, now if I'm going to do that, then I'm going to multiply through by this cos theta. So I need to make sure that I multiply every term by cos theta. So we get this. Okay, so we've reduced this down. We've still got sine and cos in it, but we've managed to get rid of the fraction. So we've reduced this down. We've managed to get rid of tan. We've also got rid of the fraction. Okay, and at this point, again, you would still need to know that you would need to change everything into cos, and the reason is because of this term here. This term is just a cos theta, it's not cos squared. Okay, so there's not really any sensible way of changing that, so it needs to stay there. So I'm going to actually write that one in now. Okay, and then trick really is that we need to change this sine squared theta, and sine squared theta is the same as 1 minus cos squared theta. So where does this come from, this 1 minus cos squared theta? Well, let's just shorten it over here. Our trig identity is that sine squared plus cos squared is always equal to 1, and we simply rearrange that and get sine squared is the same as 1 minus cos squared. This is the most common way that you would use sine squared plus cos squared is 1. So continuing in over here now, before we go any further, at least you can see now that the only trigonometric term that we've got in our piece of algebra is cosine. Okay, so we're just going to do good algebra and we're going to expand the bracket. Now I'm going to collect my cos squared terms together, and then you should recognize that this is a quadratic, so we would want to write this equal to 0 so that we could then solve that quadratic. Okay, now we don't need to solve the quadratic in part A. The question was to show that it can be written in this form, and we've achieved that. So moving on to part B, the trick with part B is to realize that this equation is exactly the same as the equation that we started with one minor change. If we let theta equals 3x, okay, then you can see that these two equations are exactly the same. So what that means is that we can use our, we're kind of halfway through solving this equation and we stopped at getting this quadratic. So really we need to continue and solve this quadratic. Now you could write 3x here straight away. Okay, I'm actually not going to do that. I'm actually going to just leave that as theta, and we'll change theta to 3x at the end rather than at the beginning. It doesn't really matter when you do it, but we do need to be careful with the 3x later on. Okay, some people like to change the cos theta into, say, a y. Okay, so you're really solving this quadratic, and then we can just change the y back to cos theta later. It looks a little bit neater doing it this way, but it's not absolutely necessary. Let's see if we could factorize this. Okay, we know that this must be a 2 and a 1 on the end to get 2. Okay, whereas 6y squared, we could have a 6y with a y or a 3y with a 2y. If you're not comfortable doing this, and I mean this lesson isn't about solving quadratics, okay, so some people are good at this, some people not so good, and you've maybe got a different method for doing this, but it does factorize, okay. So if I've got a minus here, that's going to give me minus 4y in the middle, and this will give me plus 3y in the middle, which gives me minus y. Okay, so this does factorize nicely. Okay, and if we solve that, we're going to get y equals minus a half and y equals 2/3. And all we do is change the y's back to cos thetas now. Okay, and then this is an appropriate time to change the theta to 3x. Again, we could still solve it with the theta and change to 3x in a minute. That would be absolutely fine, but I'm going to change it here. Okay, and we're now going to solve these two. Okay, and treat them as two separate questions. So I'm going to try and solve cos 3x equals minus a half. Okay, now if we just have a quick look at this graph over here, this is the graph of cos x or cos theta, and if we're trying to solve this equal to minus a half, it's effectively finding where this cuts the graph, and this is say minus a half here. Okay, so you can see with a normal cos x or cos theta, we would get two solutions in there. But we're solving cos 3x equals minus a half. So I'm just going to bring up a sketch of cos 3x. So now you can see the graph of cos 3x. If you know your graph transformations, we squeeze kind of 3 of these cos bowls into the same space. Okay, so instead of getting 2 solutions between 0 and 360, we would now get 3 times as many, 6 solutions. Okay, now the thing with this question is we're only actually looking at between 0 and 90 degrees. So 90 degrees is here, so we're only actually looking at this first bit of graph here up to here, and you can see we're going to get 2 solutions in there. Okay, and we'll get the same for cos x equals 2/3. So in terms of calculating this, the first thing that we're going to do is the inverse cosine of minus a half. So if you grab your calculator, do the inverse cos of minus a half. Okay, and make sure your calculator's in degrees rather than radians. This question is in degrees. So you should have got 120 degrees there. Okay, now the trick here, and this is an important step, what you don't want to do is you don't want to divide this by 3 straight away. Okay, you've got to understand the concept that there's an infinite number of solutions and your calculator is only giving you one of them. Okay, calculator is saying, oh, the inverse cos of minus a half is 120. Okay, but there's an infinite number of answers. Okay, and there's various ways of knowing how to find the next one. The shortcut really is that with cosine, the symmetry is that it's 360 take away this angle, so the next one is going to be 240 degrees. Okay, now if you want any more angles, you would then have to add 360 on to each of these or subtract. Now if I subtract 360 from either of these two, I'm going to get a negative number, and we don't want negative numbers here because we only want anything between 0 and 90. And if I add 360 onto 120, that will be 480, and then when I divide that by 3, it'll be 160, so it'll still be too big. So these are the only two that I need, and then I can just divide both of these by 3. So we're going to get 40 degrees and 80 degrees. Now I'm going to do pretty much exactly the same for cos 3x equals 2/3. So calculator first, inverse cos of 2/3. So that's approximately 48.19. Okay, and again the same symmetry, 360 take away that angle. That's going to give us 311.81. And again, I hope you can see that if we subtracted 360 from either of these, it's going to be negative again, so we don't want those. And if I add 360 to either of these, it's going to be way too big. So I can just go ahead and divide these by 3. So I'm going to get 16.06 and 103.94. And I just need to go and check what they want us to round it to. It says 1 decimal place, so it's good that I did more than that, and then we can easily just round these